liver pathologist. And if I had 4 hours up here, I could take you from how looking at biopsy specimens of patients and the normal tissues, what the bile duct looks like. We modified the anatomy by about 40 microns, but it turns out that finding leads me to the stuff I'm going to talk about today. It would just take 4 hours to go on that whole route. Other full disclosures, so I'm a doctor, I'm a liver pathologist, I do stem cell research. That got me into complexity theory, which you've heard a lot about and I'm going to talk about more. I'm also a lifelong Jewish practitioner, thanks Mom, and 30 years Zen Buddhist student at the Village Zendo, Roshi Ankyo Ohara. And lately, the last few years, some shamanic stuff sprung up. So, and all of that gets folded into this. So this picture comes from an artist from our Zendo who did it for a version of this talk I gave at the Zendo. So a lot of people I notice are sort of giving the overall general views in their 20 minutes and then are saving the details for later. I'm going to go into a lot of detail because, as Bruce said earlier, I wouldn't use the word gearhead. I would just sort of say nice Jewish nerdy geeky boy, but same thing. I'm going to go into a lot of detail, but I think you'll get the flavor of stuff and then I'll get to unpack it for those of you who want to hear more downstairs. So what I'm going to present is stuff that I put together with my collaborator, who many of you have heard at SAND previously, as well as in other venues. Oh, it's not here, it's there and there. A paper we published last year called Fundamental Awareness, a framework for integrating science, philosophy, and metaphysics. And so what I'm going to present is a framework, meaning it's sort of a fluffy version. It isn't a theory, it isn't a model until you've sort of mathematized it and turned it into something that can make predictions. So what I'm going to present to you is that. What we're going to go into downstairs a little bit is Minas, working with another collaborator, has managed to mathematize this, and that has implications for making predictions and understanding things in more detail. So this is the framework. And what leads us into this really wasn't a question I was interested in, but for weird reasons I got sucked into the consciousness studies world. And the big problem there is, as other people have mentioned up here, and even if not, you've heard about it, is the hard problem of consciousness. How is it that conscious beings are aware of qualia, things like the color of red, the taste of sugar, etc., experiences of consciousness? We can draw all sorts of networks in the brain that correlate with experiences, but we can't see where the experiences actually arise from. And lots of people have different ways of dealing with the hard problem. This is our way of dealing with the hard problem. So the various ways you could approach the problem really fall roughly into 3 categories traditionally. And these are sort of the human domains for entertaining this question, even though it wasn't necessarily phrased this way at the time people were thinking about these things. So first there's Western philosophy, and you have a very broad strand of central thinking throughout Western philosophy, from Plato through Spinoza, to Kant, to Hegel, saying that maybe mind is everything. That it isn't, the world of things is not the thing itself, it's what lies behind the world of things, or under the world of things, or that's reflected through the world of things. And so that's a very standard sort of Western philosophical approach, until Descartes comes in and messes things up for us a bit. And then the Vienna Circle, which you've probably, how many people have heard of the Vienna Circle, of the logical positivists? Not very many. But every single one of us in this audience is conditioned culturally to believe what they believed, and I'll talk about that downstairs a bit more too. And they were definitely opposed to anything I'm going to say today. But they were wrong. And the way we knew they were wrong, and why you never heard of them but they affected everything, we'll talk about downstairs. How many people have heard of Kurt Gödel? Gödel's incompleteness theorems, a bit more. He destroyed the Vienna Circle and opened the door for us contemporarily to consider these issues in a lot of ways. And that's something else I will talk about in more detail downstairs. And then Alfred North Whitehead, who, while the Vienna Circle was ignoring quantum physics and went off in this empiricist, hardcore, materialist sort of point of view, embraced quantum physics and all the craziness there, and developed what he referred to as process philosophy, process theory, etc. And I'll talk about him a bit more downstairs. On the contemporary science side, well, we have Newtonian mechanics, which I feel bad putting in here because, I mean, the minute we think Newtonian mechanics, that's the world acting as a machine, and everyone in this audience knows that's problematic. But Newton himself wrote far more on alchemy than he ever did on Newtonian mechanics. So he himself was not, he'd be more comfortable in this room than anyone in the Vienna Circle would be. But there it is. It's not part, as a cultural impact, world as machine obviously dominates in a lot of ways. Then there's quantum mechanics, which, duh. Important in the middle of this is the notion of complementarity, which Niels Bohr sort of encompassed, particularly in the Copenhagen interpretation. And complementarity in quantum physics is most often expressed in terms of wave-particle duality. In the double-slit experiment, things like an electron or a photon or a particle if you look at them one way, or a wave if you look at them the other way, but neither description tells you the whole thing. And I often use this kind of illustration, and I'll use it again. Is it two faces or a vase? You can't see the two faces and the vase simultaneously. Many studies have been done. You can't do it. You can move very quickly between them, but you can't see them at the same time. But you know that a complete description of this requires both the faces and the vase. But your perspective only allows you to see one or the other. This is a form of complementarity, which Bohr predicted that there would be complementarities in the biological realm, at the galactic, at the cosmologic scale, in addition to the quantum stuff, though he did not see those developed in his lifetime. But that sort of thing led Max Planck, who was you could say, the grandfather of quantum mechanics, and probably the most conservative scientist of that crowd, given his generation. But even he looked at the data from quantum mechanics, and I don't know if someone already quoted him, Deepak might have used this quote earlier today. I regard consciousness as fundamental. I regard matter as derivative from consciousness. We cannot get behind consciousness. Everything that we talk about, everything that we regard as existing postulates consciousness. So the quantum physicists were firmly and comfortably in this room. Relativity provided us, Einstein was not comfortably in this room, but he provided us with two very important concepts: the equivalency, the complementarity of energy and matter and mass, and space-time. Which you've heard about, you know about, but we'll bring that into the equation too. And then these two meet in the notion of the quantum foam, the quantum vacuum being an energy-rich field of space-time. Energy turns into mass, so you get eruptions of particles, usually in matter-antimatter pairings. They annihilate each other, fall back into the quantum vacuum, so there's this bubbling, foamy sort of quality. But some of those escape that self-annihilation, and if they do, they can interact with other smallest things, strings or whatever they are, to self-assemble into subatomic particles, into larger subatomic particles, into atoms, etc. And then there's complexity theory, which gives us the overall theme for the conference, this idea of emergence. And so what we're really talking about are self-organizing systems, and that self-organizing systems, as you've heard, as you know, give rise to phenomena that are not contained within the individuals making up the system. It just sort of magically happens at the higher scale. So a very common example that people talk about are ants. And you see a food line of ants, and it looks like the ants know where the food is, and they know where the ant colony is, and they form a perfectly straight line. And ants self-organize. There's no ant governing what happens in the colony. There's just ants doing what they do locally, interacting with other ants in their environment. And somehow out of those interactions, they self-organize into a colony, into food lines, into a dump for refuse from the colony, into a cemetery, etc. How they do this, the key thing is that these are adaptive. And so how does something like this, which seems machine-like, allow for change and adaptation and evolution? Well, there's always some degree of randomness in the system. And I'll unpack this a little bit more downstairs as well. But this randomness in the system, too much randomness, you don't get self-organization, you just get disorder. Too little randomness, and if the environment changes, there's no way for that ant colony to find a new way to self-organize to meet the changing environment. So if you step your foot down in the middle of a food line, it's one of these ants that's not part of the food line that very rapidly leads to finding a route around your foot. Someone else has to be searching out the new food sources. Otherwise, when this food runs out, where do they go next? So this randomness in the system is essential for emergence that's adaptive. And this is how I got into this work, and what leads me here is I met an artist named Jane Prophet in England who was interested in this sort of thing, and she introduced me to these concepts, and we realized that I can apply this to stem cell biology. So you have this typical, it's totally fake, but it's a typical schematic for stem cells in any organism, and you have the cell on the left that divides, giving rise to partially differentiated cells. They divide, they become more differentiated, until on the right you have these terminally differentiated cells, the mature cells of your body. And this is always left to right and hierarchical. It's a machine. There's no room for adaptation in here. But we're a living system. Where does the adaptation come in? And so when I was doing adult stem cell plasticity work, this was where we were finding, it was our work that led to George Bush's address to the nation about embryonic stem cells, because we were showing adult cells could do everything that embryonic stem cells could do. But in the experiments, it was always happening, almost always happening at very low levels, 1 in 100 cells, 1 in 1,000 cells. And so people who were sort of opposed to that work said, well, it's a trivial result. It doesn't really matter. But if you think about it as the quenched disorder in the system of a complex system, that when we developed our techniques for looking more closely at the tissue and saw these rare events, this is that quenched disorder like the divergent ants. And so this is what allows for flexibility and adaptation. And we wrote a series of papers on this. So this is where it started to get weird for me. You see an ant colony in the distance, it looks like a solid thing. It may be changing shape or moving around a little bit, but it looks like a solid thing. You walk up close and look at it, and you see, no, it's not a thing at all. It's just a bunch of ants self-organizing. But what I just told you is that cells that make bodies are doing the same thing. And so if you look at the ant microscopically, or at my hand microscopically, you see that it's not an ant or a hand at all. It's a flock, a crowd, a colony of single cells that are self-organizing into something that at this level of scale looks like an object. But it's not an object. So this opens up the idea that whether something appears to be a thing, as opposed to a phenomenon arising from smaller things, depends on the scale of observation. And that's a form of complementarity. My hand is a hand. Yeah, kind of, but at the microscopic level, it's actually just a colony of cells. There's no hand there, it completely disappears. That doesn't quite capture it, because it's a hand that can grip this and advance to the next slide. So you see this in lots of places in the world. A bait ball of fish. From a distance, this looks like a ball. But you know it's made of fish. But the fish themselves look like fish, but you know they're made of cells. Flocks of birds in the sky, same thing. So putting this into a general scheme, we know the quantum vacuum is what's at the bottom. At the top, at this moment, we're talking about bodies. And bodies exist at this level of scale, but at the next level of scale, they're just colonies of cells. So are cells a fundamental unit? Well, not really, because at the nanoscopic level, they're just biomolecules floating in water, right? So they look like cells. Lower down, there's no cell there. They're just molecules. And molecules are self-organizing atoms. Atoms are self-organizing subatomic particles. And those are just the smallest things coming in and out of the quantum foam. There's nothing, no object that has inherent existence anywhere in this scheme. Nothing actually exists as a thing. And if we run this back the other way, this is a form of complementarity too. The quantum vacuum and the quantum foam. It's not one, it's not the other, but you can only see one or the other at the same time. You have to know that they both exist. And those self-organize through what we call process, using a word from Whitehead. You heard Tim use it earlier. And so this goes back up through levels of scale until you get to the entire universe. And this whole thing, the way this goes round and round, and this had echoes in Bruce's talk earlier with these cycles, that's what we call recursion. And so all of these things happen all the way through. So is the quantum vacuum where everything begins? Maybe, and there are scientists and consciousness studies who believe that. But we wanted to know, is there another possibility here? And Minas and I both have either academic or personal experience in Buddhism, Shaivism, that these things, this is why these are in the circle, though many other systems of thought and experience contain these. All of these point to something deeper. So in Buddhism, there's talk about the mind of clear light, reflexively self-aware primordial wisdom, awareness of awareness. In Jewish mysticism, the Kabbalah, there's the Ein Sof, which is without end, without limitations, indescribable by words or concepts. And in Vedanta thought, the ground of being, etc. All of these things, they're complementary explanations. They don't completely overlap, but they all give us a perspective. So what if we take these seriously and posit that that's what's underlying everything, and that that's what gives rise to the quantum vacuum, etc.? And it makes sense when you think about it, because the non-dual has no subject or object. There's no other and self to be observed or observe. And so if such awareness, pure awareness, non-dual awareness, begins to examine itself and becomes aware of itself, and this is something explored in detail in Shaivist thought, which I'll go into more detail downstairs, then you see how the non-dual, as it starts to become aware of there's a this and a that, or an I and a that, and they're still the same thing, but there's some differentiation. As these start to separate into subject-object, then you need separation in space and time. And all of a sudden, you have space and time. And they give rise to space-time, which is an energy-rich field. And then the whole thing springs into existence. So it fits if we want to include these experiential concepts from all these different cultures and practices, which are data for forming our theory. So we want to take this data seriously and incorporate it into this framework. So some implications. Boundaries, materiality, are scale and perspective dependent. So my finger stops at my skin at this level of scale. Next level of scale, I've been shedding cells and bacteria all over the place. How many hugs and handshakes have I had today? And so we're a cloud of the microbiome that I brought in and everyone else brought in, et cetera. If you live with anyone at home, dogs, cats, people, you share a microbiome, and you're actually a big microbiome that happens to have some human elements. Molecular level, so this idea that at scale goes down, your boundaries get wider. At the atomic level, there's no atom in your body that you didn't eat, drink, or breathe from the planet. So you can see us as beings that live on Earth, or you can say we are Earth that has self-organized to sit in a room together and talk like this. And in the same way, we don't live in the universe. The universe isn't a space, a box. We are the universe, arising from its substance, or in Buddhist terms, the relative and the absolute. I'll go into Vedantic and Jewish stuff and Shaivist stuff downstairs in more detail. So this is the final paragraph from the paper we wrote. In summary, fundamental awareness is a formalized version of an oft-stated, though as often neglected, point of view, that non-dual awareness is foundational to the universe, not arising from the interactions or structures of higher-level phenomena. The universe is non-material, self-organizing throughout, comprised of a holarchy, not a hierarchy. I have to draw it that way, but it's all present, all simultaneously. A holarchy of complementary, process-driven, recursive phenomena, and is both its own first observer and its first subject. The cosmos, therefore, can be understood to derive from awareness rather than being suffused by it or giving rise to it. To say that the world is non-material and comprised a priori of awareness is to privilege information over materiality, something you've heard over and over again. Action over agency. In such manner, a proper understanding of human qualia reflects that qualia are not a hard problem to solve, but the foundational nature of all existence. All views and experiences are in fact nothing but qualia within the awareness that is the ground of existence. Every field, every wave particle, every atom and molecule, every living and non-living aggregate of such, anything and everything observed, experienced, or imagined is in fact nothing but qualia within the awareness that is the ground of experience. In this view, the human brain is not the creator of our conscious experiences, but the transducer of the fundamental, non-dual, non-material consciousness into our own personal human minds. So these are the things that I'll be going into downstairs. The mathematization, Gödel's, all the stuff I talked about. And my favorite, why the universe exists. But you get that if you come downstairs. I'll finish with this quote. The Sufi says this whole universe was made in order that God might know himself. The seed wished to realize what it is, what is in it, and therefore became the tree. Thank you.
Hey.